Hi, it's Kelsey, and today I'm going to be showing you how to do the third free response question of the 2011 AP Calculus AB exam. So to start off, they give us this information. They say, let R be the region in the first quadrant enclosed by the graphs of f of x equals 8x cubed and g of x equals sine pi x as shown in the figure. So we're looking at this region right here, that this point of intersection is 1/2, 1, and this one is 0, 0. So for part A, they're asking us to write an equation for the line tangent to the graph of f at x equals 1/2. So some important things that we remember that they gave us about f is that f of x equals 8x cubed, and they also gave us the point that f of 1/2 equals 1. So in order to find the equation for the line tangent to the graph, we have to find the instantaneous slope of f at this point, and in order to do that, we find the derivative. So first of all, the general derivative is going to be 24x squared, and then we evaluate that at 1/2, and we get 24 1/2 squared. So 24 times 1/4. So m equals 6, or f prime of 1/2 equals 6. Now we're going to write an equation in point-slope form, and I choose personally to do point-slope form because I think it's the easiest one to write out, but College Board will also accept the standard form and slope-intercept form. So we have the point at 1/2, and we also have the slope at 1/2, so we can just write in point-slope form y minus y1 equals the slope times x minus x1. So an important thing to note here is that when the College Board is grading you, they're looking for 2 points in this for this question. And 1 point goes to having written out f prime of 1/2, and another point is for actually writing out the equation of the tangent line. So it's important to make sure that you show all your steps when you're doing your work, because you never know what they could be looking for in a problem. But for this specific type of problem, that's what they're looking for. For additional practice on writing equation of tangent lines, you can visit pages 150 to 151 of our calculus textbooks, and there are plenty of problems to work with. So since this is on the non-calculator portion of the FRQ, we're going to have to actually evaluate this because we can't just plug it into our calculators. So how we do that is, what I'm going to do is separate these two because there's a subtraction sign. So for this, we're going to have to do a u sub, and I'm going to set u equal to pi x, and then du is going to equal pi dx. And then you just actually plug these numbers in. And so when we finally work all that stuff out, we're going to end up with an answer that is 1 over pi minus 1/8, or negative 1/8 plus 1 over pi. It's the same thing. And what the College Board is looking for this problem is actually a couple of things, because it's 4 points. So they're looking for this integrand because they want to be able to follow and assess your work. And they're also looking that you did the proper antiderivative, so they're looking for these two. And then, of course, the final answer. But the final answer is only 1 point, so the thing that carries the most weight in this problem is going to be the antiderivative. So making sure you have that u sub down is really important. For more practice, visit page 420, number 5 through 28 in our calculus books for more area between two curves. For the final portion of the question, they're asking us to write but do not evaluate an integral expression for the volume of the solid generated when R, which is the region that they gave us before, so it's this guy, about the horizontal line y equals 1. So I'm just going to take this back and draw a line at y equals 1, so I have a visual. And they're asking us to revolve it around this, so when you actually draw it, this comes up here. It's going to look... This is a really rough sketch of what it's going to look like when it's revolved, but you can tell that there's going to be a hollow section, so it's going to end up being a washer because there's an inner radius and an outer radius. So if you recall the formula for washers, it is pi times the integral from a to b, so the two numbers, outer radius minus the number, which is going to be the y equals 1 in this case, squared, minus the little or inner radius minus the number squared, and then d whatever variable you're using. Now for us, we already know what the interval is going to be, so we can just plug that in. And if you look at this, you can see that this is going to be the inner radius, and that's the outer radius, because when you're rotating it, this is going to go over, if that makes sense. So the outer radius is going to be the 8x cubed function. So we have 8x cubed minus 1 squared minus, and then the inner radius is going to be this function, which is the sine pi x. Minus 1, of course, squared, and then dx. This problem is where 3 points, they're giving you 1 point for the limits and constants, so they're looking for this pi out front and also the interval that you're using, and then, of course, also just this entire integrand. For more practice on revolutions, you can visit page 436 and 437 in our book. There's plenty of problems to work with.